Hi, grade 7. This is the math video for lesson 1-8A, page 44, numbers 4 through 14. Before we get started, please pause this video and read through page 43 and then come back to this video. Go ahead and pause it. Okay, so you're back, and hopefully you understand that the lesson is about working backwards. If you don't get or understand the problem on 43, you might want to talk to me about it. Let's take a look at a different problem. Let's imagine that a girl named Wendy is meeting some friends for dinner and a movie. She needs to be finished with dinner by 7:30 p.m. So I'm going to write that down. Finished with dinner by 7:30 p.m. And she needs to do that so that she can get home by 8 p.m. Let's see, the movie takes 90 minutes. And she wants to have at least 1 hour for dinner. If it takes 20 minutes to get from the theater to the restaurant, 20 minutes, theater to restaurant, what is the latest starting time she can choose for the movie that she wants to see? The latest starting time for the movie. Latest starting time. That's what we're looking for here. That's the big question. The latest starting time for the movie. Can we see all that? I think we can. Okay. So, let's take a look at this. Dinner needs to be finished by 7:30. She needs to get home by 8. The movie is 90 minutes long. 1 hour for dinner. And 20 minutes from the theater to the restaurant. So the latest starting time of the movie. Okay, so what in the world's going on here? It looks like we've got home, and then she leaves home, and I think based on everything that this says up here, she's going to go to the theater first, then the restaurant, and then back home again, right? So she's starting off at home, going to the theater, then the restaurant, and then home again. So let's try to backtrack. If she wants to be at home by 8 o'clock, and it says that the dinner has to be finished by 7:30. And it says here 1 hour for dinner. That means she better be at the restaurant starting to eat at 6:30 to 7:30. So this right here is her restaurant time frame. But it also says that it's 20 minutes from the theater to the restaurant. So that means she needs to leave the theater 20 minutes earlier than 6:30. She needs to leave the theater at 6:10 because that's 20 minutes earlier, right? So this is going to be part of my theater time. She's leaving the theater at 6:10, and the movie's 90 minutes long. So if I got to back up 90 minutes, how can I back up 90 minutes from 6:10? Well, let's back up an hour. Backing up an hour from 6:10 would put it as 5:10, and 5:10 is that hour is 60 minutes. We need to back up another 30 minutes from this time. If I back up 10 of those 30, I'm at 5 o'clock. And if I back up another 20 minutes, I'm at 4:40. Is that all on the screen? Looks like it is. So what was I trying to accomplish here? If I know I have to leave the theater at 6:10, And I know that the movie is 90 minutes long. Backing up 90 minutes would take us 60 minutes to 5:10, another 10 minutes to 5 o'clock, and another 20 minutes to 4:40. Seems to me the movie has to start by 4:40 p.m. The movie has to start by 4:40 p.m. Notice how writing all of this down helps. It's part of the 4-step plan, right? Exploring, planning, solving, and then examining. Now let's make sure it makes sense. Let's go the other direction. If the movie's at 4:40, the start time, and the movie's 90 minutes long, if I go ahead an hour from 4:40, that's 5:40. Another 30 minutes past 5:40 would take us to 6:10. And then 6:10 to 6:30, I would be walking from the theater to the restaurant. And then I'm eating at the restaurant for an hour. That would give me a 7:30, and I could get home by 8. So 4:40. Okay, let's go on to page 44. I'm going to help you with the first one. McCall's great-grandmother was 6 years old when her family came to the United States 73 years ago. So the grandma was 6 years old, and that happened 73 years ago. And then it says, if the year right now is 2003, when was her great-grandmother born? Well, right now, supposedly it's 2003. When was she 6 years old? Doesn't it make sense that we have to take this 2003 and subtract 73 to get, Nope, didn't need to do that. Went too far, excuse me. That's wrong. This is 0, so I got to back up to here. This is 1, this makes 10, 9, so this makes 10, 3, 9, 1. Oh, in 1930, she was 6 years old. Because you back up 73 years from this date, in 1930 she was 6 years old. We got to back up 6 more years because we're trying to find out when she was born, the year of her birth. We know that 1930 is 6 years old, so let's back up another 6 years. Oh, must be 1924. Any questions about that? Let's go on to number 5. The cash receipts in Brandon's cash drawer total $823.27. His cash out receipts are $734.87. If he currently has $338.40 in his drawer, what was his opening balance? Well, I'm guessing some of those terms you've never heard before. So let's try to think through what we're talking about. When it talks about opening balance, that's how much money he had at the beginning of his shift when he's working. At the beginning, he had a certain amount. And do we know that amount? No, we don't. So opening balance, I'm going to write it opening balance with a question mark. And then it says the cash in receipts were $823.27. Cash out receipts were $734.87. Cash in means money going into his cash register. Cash in, money going in. Cash out is money leaving his cash register. Okay? And finally it talks about at the present time he's got $338.40. So at the end he's got this amount, $338.40 at the present time. So he's got this unknown balance. Cash in is $823.27. So that amount of money was put into his cash register. So it's his opening amount, his opening balance, plus this money that goes into his cash register, but then subtract this amount because that money has left his cash register. He needed to make payments to people apparently. So add this amount, subtract this amount. Okay, now what do you do with this to figure out his opening balance? I'm going to give you a simpler problem to think through here. What if instead of these numbers, you had these numbers? 800, 700, 200. How would you work backwards? How would you work backwards? Well, you could guess and check, but guessing and checking is not the most efficient way to do this. Watch this. If the last thing we talked about was subtracting 700, let's add 700 to both sides. In other words, we're doing the opposite of subtracting 700. And when we do that, we got 900 on the one side, and we're left with the opening balance plus 800 on the other side. Now, what's the opposite of adding 800? Well, let's subtract 800 from both sides. And when we do that, we get an opening balance of $100 in this case. Now let's check and make sure that makes sense. If I put 100 here, 100 plus 800 is 900. 900 minus 700 is 200. So we worked backwards doing opposite operations here. First, we added 700 to both sides because of that. Then we subtracted 800 from both sides because of that right there. And we got our opening balance. You're going to do the same thing with this problem. Add this amount to both sides first, then subtract this amount from both sides next, and you should get an answer. Let's go on to number 6. Go on to number 6. Number 6 says, what may have happened between 10 a.m. and 11 a.m.? Well, when you look at the graph, it's about Mr. Parker's car trip. And the dot at 10 a.m. is about at, I'm going to say around 140 miles. And the dot at 11 a.m. is about at 140 miles. If you look carefully at the graph is comparing time to distance traveled. And it starts with 8 a.m. at 0. 8 a.m. we're at 0. And then we can go up 9, 10, 11, 12. How far does it go? 1 and 2. 9, 10, 11, 12, noon, 1 and 2, right? And the first dot is at 9 a.m. at about 75. So I'm going to call this 100, about 75 there. There's 50. And then 10 a.m., we said it was about 140. So that would make this 200 right here. So 10 a.m. we got about here, and 11 a.m. same mark. So we're looking at this dot, and we're looking at this dot, and we're trying to figure out what's happening between these two dots. From 8 a.m. to 9 a.m., he traveled 100 miles, right? From 8 a.m. to 9 a.m., maybe about 75 miles, I'm sorry. From 9 a.m. to 10 a.m., it looks like he traveled about another 70 miles. Because this is about 75 and this is about 140, maybe 65 miles. Then all of a sudden, from 10 to 11, what happened? The distance doesn't go up at all, does it? What do you think he was doing? Do you think he got in a car accident? Or maybe he stopped for a bathroom break? Or maybe he stopped for breakfast? Or maybe something like that. Describe what you think happened between those 2 hours. Let's go on to number 7. It says Mr. Parker's trip is going to cover 355 miles. If he keeps maintaining the speed set between 11 a.m. and noon, when should he maybe get to his final destination? Well, 11 a.m. to noon, the number jumps to 200 right there. So it's going like that. And we're trying to figure out when he's going to get to 350 miles. So I'm going to erase this and extend this higher up, because we've got to get to, where's 355 miles? Yep, that'll be about right here. That's the line for about 355 miles. When does this line get to that line? Right? Oh, what do you think? What time is that? Okay, I'm going to let you work on the rest of these on your own, but if you get stuck, please talk to me. See you later.